So here's our team. I'm James, the project leader. Last quarter we had 12 people. This quarter we have 18. Now we have 6 subgroups, each of which is working on their own separate aspect of the project. And we do pretty much everything you could ever want to do with Simulcast Lectures. But first, what is Simulcast Lectures? So here's our project. We built a computer about 10 months ago that has a touchscreen interface. And what you do is, if you're giving a presentation, you bring your laptop to the class, and you plug it in to our computer system. And once it's plugged into our computer system, it goes out through a projector. It gets streamed live, so if all of you have laptops open right now, you can be watching this live stream here or anywhere in the world. And we save it as a PowerPoint and is a video. And of course, all of this is synchronized with the audio. So if I was a professor, I'd have my microphone, you'd be all able to listen to me, and you'd see the slides as they change in real time. But what does our system actually do, and what's this stuff about touchscreen? So, here's my finger, and here's it going all over the screen. And I just enhanced our lecture. So, we can also change the color. We can go, so I'm highlighting the project, and this computer. And now I'm highlighting the projector. Very important, you just gained so much knowledge from my lecture. Okay, moving right along. So Kevin and I, last October, went to New York for a conference. We went for the User Interface Software and Technologies Conference. This was actually at New York University, and it was pretty cool because we ended up winning an award for the most useful application. And there's us holding our awesome awards, these little tiny things, and holding this keyboard. Now this keyboard is a Microsoft adaptive keyboard. Every key is an LCD screen, and then the top is a touch screen. And what you can do is you can scroll through the top through your various slides. Now what we did is we offloaded a user interface onto this keyboard. Now a user interface is what you interact with every time you interact with a computer. So when you're looking at Windows and you're like clicking on tabs and buttons and all that stuff, that's all a user interface. And someone somewhere wrote that, and they made it so that you can interact with it. Now what we're doing is we're writing software like that allows you to interact with these user interfaces. And I have some more about user interfaces later because that's so important. Anyway, streaming architecture. A bunch of technical stuff as to how we actually get it to stream live. It's not very easy, but we did it, and it works. Operating system. This is a Windows machine, this is a Linux machine. If you ever meet anybody who works with Linux, they probably know what they're doing. Enough said with that. I don't know if any of you use Linux. Does anyone here use Linux? You do know what you're doing. Probably. I don't know. Okay, going right along. So what's the novelty here, right? What makes this an amazing project / future product / awesome thing? It's the fact that we can plug any computer into our computer and redisplay what was on the original computer on a screen in our computer that you can then draw on and stream live to a projector that then goes to everyone in the world. What did you just say? So, it's these things, these VGA capture cards, or capture cards in general. Now what a capture card allows you to do is it has an input on it that takes VGA in. On laptops and on all computers, the graphics cards have VGA out. So when you plug a VGA cable into that computer, that stream goes out, hits the touch screen, hits the projector, goes everywhere, but it can't go into another computer. So what the capture card allows you to do, it looks just like it looks like an ugly graphics card really, but what it allows you to do is it allows you to capture the content from the original source computer. So from this laptop, this screen is being captured and redisplayed on a screen in this computer. And what we're doing is next quarter we're going to be working with these PCIe-based HDMI capture cards. So these HDMI capture cards are a lot cooler, they look nicer than the other ones, and we use them in conjunction with these converter boxes. So when you're working on the project, you have a budget. And when you have a budget, you kind of have to figure out what are the cost-benefit trade-offs. Now with us, we looked into VGA, or VGA to S-video conversion. We looked into PCI-based HDMI capture cards and then VGA capture cards. Now, when you're looking at the trade-offs, it makes the most sense to go with the PCIe HDMI capture card setup. And that's what we're shifting towards, because we have the VGA and we have the S-video. We have two systems here. The Windows system is running the VGA capture card, and this Linux system over here is using a S-video capture card with an S-video conversion box. So it's pretty cool. And we're prototype 1, prototype 2, and prototype 3 later on. We have some printers and stuff, which I'll get into in a minute. Back to the UI. We have a couple of concept designs, different layouts, things like that. When you put it onto a screen, it looks cool and amazing. How do you make it work? That's always a fun question. How do we do it? We use GTK+. This is a great little library. Actually, it's not that little, but for coming up with the layouts of user interfaces. So you're looking at your computer screen, you don't know how you're going to get the user to interact with all the different features. That's why you use GTK+. Then you have clutter, which is the prettier way of organizing user interfaces. So if any of you are going into computer science or anything like that, you should be like, oh, I want to learn how to use clutter, and then you should, because it's like awesome and it looks pretty. And now I'm just going to like jump around to random points in this presentation. But what this project entails is we are now running it as a class called Engineering 100L under the banner of Smart Classroom or Simulcast Lectures, or just basically this place. You come here and you work on this stuff. What is Engineering 100L? Engineering 100L is a project-based class. It's part of TIES, which is the Teams in Engineering Services group here. There are 11 other lab classes that are under the TIES lab banner. And what we do with TIES is we do humanitarian engineering. So with Simulcast Lectures, this is a tool that we're developing to benefit the world ideally by distributing and capturing lecture content that will then benefit the lives of many other people by them being able to have access to these lecture materials. People in far-off places like Africa or parts of Asia where they don't have the education that we have access to, they can now watch it via live stream or watch the videos later. Now, one of the other areas of research that we're working on is not represented very well in these slides, but it's building touchscreens. So we are building a touchscreen that is the size of this table, and we're doing it for $500. Right now, if you wanted a touchscreen that was the size of this table, it would cost you $60,000. So how do we do it? Well, it uses this stuff, which is a matrix dot array on a piece of paper. Now, instead of using paper, we use transparencies with the UV fluorescent ink in conjunction with a pen that has a camera and a UV LED. And there's some software that we're working on to make this all work, and it's magic and it's awesome, and maybe it will be on the market one day, so you too could put a touchscreen overlay on your big screen TV and then be able to interact with it as though it were a whiteboard. That would be really fun and awesome. Other than that, we have a note parsing feature. The note parsing feature is when the students are watching the live stream of the lecture on their laptops, they're logged into our website under their user account. And on that user account, they have the option to take notes if they choose to. If they take notes in real time, it's time-stamped with the lecture. And then what we're able to do is take a democratic note parsing algorithm that takes the aggregate of everyone's notes in the class. And when you take everyone's notes at the same time, you can look at the note frequency distribution. And when you look at the note frequency distribution, there's a high correlation between when people take notes and when there's important content in the lecture. So what you can do is look at the 10 most frequent moments in a lecture and then chunk a 50-minute lecture into a 5-minute video. Basically what it means is if you're trying to cram for a midterm the night before and there's like 20 lectures you have to review, you now just get to watch like an hour's worth of video instead of trying to listen to 20 hours worth of podcasts that are desynchronized with 20 hours worth of PowerPoint, and it's all really confusing and hard, so it's frustrating. Then we're working on that. The last feature, well, one of the other features is right now for content management systems at the university level, what professors will use is they go through WebCT, which is part of Blackboard, which allows them to upload content. The students can then download that content later. We're switching over to Moodle with the CSE department. So with Moodle, we're working on doing a couple of different novel features there with uploading and downloading, things like that. In addition, we're going over polling. So at UCSD, one of the big problems we have is attendance, right? How do you get students to show up to lectures? How do you track, monitor attendance, things like that? And one of the things you can do to address that is using the clickers. So some professors will use clickers, which are synchronized with your student ID, and then that gives them a roll sheet of who was there in class that day. But not everyone likes using the clicker system. Not everyone wants to use the clicker system. So we're making this attendance tracking / polling feature available to everyone using, it's going to be a feature on our user interface that will allow students to respond via clicker, laptop, or cell phone. So if you're in the class, your professor can just push a button to take roll, essentially, and then if you don't reply within the area, then you're not in the class that day and they'll know that you weren't there. And then there could be repercussions for that, like if you miss 4 classes or something, you get locked out of the content that's available on the website, stuff like that, until you talk to your professor at office hours, whatever you want. But this will ideally revolutionize education at the university level, as well as anywhere else in terms of applications and knowledge, stuff like that. Does anyone have any questions?